Hi, Aiden. We're going to make another video, and this time I have Anderson and Connor here with me. Luna's in the background, but that was Anderson being silly. All right, let me go ahead and we'll get going today. I'm going to give me a second to refocus this camera because Anderson was in there. I hope you guys are doing good. I'm going to text your mom here soon. Have you guys started school? And if so, how's that going? Um, okay, so for this video, my goal is at the top, compare and order fractions. We're going to compare and order fractions a couple of different ways. I'll teach you kind of something called comparing with benchmark fractions. We'll follow what they do in the book, and then I showed Anderson, it's the way I teach my students, and he actually liked that way the most. So let's start first with benchmark fractions. I'm going to erase this. I had that there for Anderson. But benchmark fractions, what I'm talking about is if we take a look at this ruler, okay, all of these are fractions within a whole. And we know 1/2 is halfway. We know 1/4 is smaller than a half. We know 3/4 is greater than a half, but less than a whole. We also know that we have 1/8 in here. So again, this is how you can compare your fractions. You can say, oh, I know 1/8 is smaller than 1/2. 1/8 is also smaller than 1/4. But all the way over here, now I have 7/8. 7/8 is greater than 3/4. So knowing this is how you can use benchmark fractions in your comparing, okay? So you don't always have to change a fraction. That's what we'll talk about next, is changing the fraction another way to compare and order fractions. So I'm sure you've also seen a measuring cup. It's kind of hard to see, but again, you have your 1/4 down here, 1/3, and actually it might be easier to see this if I had a plain white piece of paper here. This isn't quite plain, but it might help a little bit here in a pinch. You can see these a little bit better, hopefully. The lighting is really hard. There we go with the lighting. So 1/4, 1/3, 1/2, 2/3. So you can see where 2/3 lies in relation to 3/4. No, put those away, please. And again, you can use these benchmark fractions in comparing, okay? So keep that in mind with our goal today. So moving on to the actual lesson in the paper here. What you can do is, you know, they want to compare the lengths of ladybugs, and you can again know, okay, well, I know 1/2 is greater than 1/4, but maybe you're not quite sure where 5/8 and 3/8 lie within 1/2 and 1/4. Well, what you can do is you can make it so they have the same denominator, and this is what Anderson preferred. So this is creating those equivalent fractions with, and if I want the same denominator, my denominator is going to be 8. So here I have 8 and 8. And so again, to go from 2 to 8, I multiply by 4. So my numerator will be 4. I have 4/8. To go from 4 to 8, I multiply by 2, and so I have 2/8. So if I want to compare right now, 2/8 is my smallest, and so going from smallest to greatest, 2/8, 3/8, 4/8, 5/8, okay? And if we keep going, 7/8 will be the greatest fraction, while 8/8 will be a whole, okay? So the way that this is listed here in Anderson's book, where when the denominators are the same, the fraction with the greater numerator is the greater fraction. So what I just said, but written out in words. So what this means, 2/8 is smaller than 3/8, and if we want to know what is longer, that whirligig beetle is longer. Okay, I'm going to go ahead and turn the page. Connor, excuse me, I'm going to move the book right here. Thanks, bud. So the other thing that this book does is it makes equivalent fractions, but they do it another way, where if you create it so it has the same numerators, okay, the fraction with the greatest denominator is the least fraction. And so this kind of threw Anderson off because now you're going in an opposite direction, or it's like opposites. Now we're comparing denominators. But again, if you wanted to create equivalent fractions, you would compare, or would create equivalent fractions, you could compare the numerators, and then again, with the largest denominator, that's your smallest. Okay, so 10/12, this is what helped Anderson a little bit, is really close to 12/12. And remember, 12/12 is a whole, so that's why this one is the greatest. But what Anderson and I did up here is we did practice some more with creating that same denominator. Oh, sorry, the lighting, I think because it's early in the morning, the lighting's not the greatest. So 1/4 is the same as 3/12. 5/6 is the same as 10/12. 2/3 is the same as 8/12. Okay? So, again, you can compare least, so 1/4, to greatest, which is 2/3, which is the very greatest, 5/6. Okay? So if I wanted to write this out, again, I have 1/4, 2/3, and 5/6. They have that model. Anderson did this on a couple problems where he did draw out the actual model and shaded and compared that way. So that's another way. So there's lots of ways, lots of tools to be able to compare and order fractions. So just a quick recap before we practice some together is benchmark fractions. Remember, just knowing your general fractions, making a common denominator, making a common numerator, or drawing out the model. Okay, so let's go ahead and practice a few, and then that'll be it for this video. So this first example, this is a great one to use the benchmark fractions that I started the video with, where knowing that 3/4 is greater than 1/2. Okay, so again, just trying to picture that measuring cup or the ruler. And so a greater than symbol goes this way. What Anderson did on this one, 3/6 and 3/4, well, he realized, well, 3/6 is the same thing as 1/2. It's simplified. Yeah, you can do what with Luna? Oh, not right now. We're gonna, Connor wants to make a video of Luna and share that with you. So we'll try and do that maybe after this one, and I'll do it on my phone. It's a little bit easier. So, but anyway, again, we have benchmark fractions, just like number one, and so now we know that we have a less than symbol. Okay, let's come over. Now I can put this book away and use my paper. So again, Anderson, I remember he saw, well, 2/6 is can get simplified to 1/3, and now my two fractions are equal. Okay, so these are other tricks to do it, and then again, you see that you have a common denominator, that your numerators are also the same, so it is equal. Now, I remember when Anderson and I got to problem number 4, he's like, oh, I can't use benchmark fractions quite so easily, and that's okay, and that's where we're going to use one of the other tools of either getting a common denominator or a common numerator. Again, for Anderson, he preferred that common denominator. So a common denominator, this is where multiples are important. So what is the least common multiple between 5 and 6? One way to do it is sometimes multiply the numbers together. So 5 times 6 is 30. And we know that both 5 and 6 go into 30. So we would have to do 5 times 6 to get 30. So we're going to do 3 times 6 to get 18. 6 times 5 to get 30, so that means I'm going to do 5 times 5 to get 25. Since 25 is a greater numerator, we know 25/30ths is the greater fraction, so 5/6 is greater than 3/5. Okay, let's try another one. Number 5. So number 5, you can create an equivalent fraction. So we have 4/5 for a common denominator, or we can simplify 8/10. Okay, I think Anderson and I skipped this one. But if I wanted to simplify 8/10, my answer is 4/5, and I see that it is equal to. Okay, try number 6. So number 6, again, we can use those benchmark fractions. We just know that 1/3 is smaller than 2/3. But they do have a common denominator. We know 2 is greater than 1, so 2 is the greater fraction. Let's jump over to number 8. So number 8 is one where you can use benchmark fractions, or you can create that common denominator. So let's create a common denominator for number 8, just so you get a little bit more practice with that. So for a common denominator, what that means, I have to find the least common multiple for 3 and 8. And the least common multiple is going to be 24. Okay, both 3 and 8 go into 24. We have to do 8 times 3 to get 24, so I'm going to do 5 times 3 to get 15. We'll do 3 times 8 to get 24, so then it'll be 2 times 8 to get 16. And then I see that 2/3 is greater than 5/8 because it's 16 is greater than 15. Okay, so what you can do is you can practice the rest of these 7, 9, 10, 11 on your own if you want. The last thing that we're going to do is order these from least to greatest. Again, when you order, use benchmark fractions to help you, or get that common denominator. Okay, so if I look at just my denominators, 6, 3, and 3, okay, I know that I can simplify 4/6 to have a denominator of 3. Okay, I would just divide by 2. It's reducing. So 6 divided by 2 is 3, so that means 4 divided by 2, I get 2/3. Now when we order this from least to greatest, we're going to always write it in the original fraction. 1/3 is my smallest, then 4/6, and then 3/3 is my greatest because that's a whole. For number 13, Anderson did use benchmark fractions on this one, so he just knew exactly the order to do it. But if you don't see that, again, create the common denominator. The least common multiple for 4, 3, and 8 is going to be 24. Okay, so we're going to redo each of these fractions with 24 as our denominator. So 4 times 6 is 24, so 3 times 6 is 18. 3 times 8 is 24. Don't let her bite you. 3 times 8 is 24, so 2 times 8 is 16. 8 times 3 is 24, so 7 times 3 is 21. And we can now order this. Again, compare the numerators because they have a common denominator. We're going to rewrite it in the original fraction. So my least is 2/3. Then we have 3/4, and lastly 7/8. Okay? I know this video is getting kind of long, so I appreciate your patience. Let's just practice one more. If you're confident, you can stop the video now, but if you want to see one more example, here is 14 for you. And so what I'm going to do, again, is create that common denominator so I can compare the numerators. And I'm going to think of my least common multiple for 10, 5, and 8, and it's going to be 20. Connor, be careful, please. And so this is my scratch work. And so from 3/10, I'm going to multiply by 2, so I have 6/20. From 3/5, I multiply by 4, or 4/4, and then I have 12/20ths, and then the last one, I'm going to multiply by 3/3, and I get 9/20ths. Comparing from least to greatest, in the original form, 3/10 is smallest, then 3/4, and lastly, 3/5. Okay? All right, that's it for this one. Again, you can practice the rest of these on your own if you want, and then I attached another sheet. That's what I had Anderson do on his own. All right, bye.
Bye.
Yeah, take care, bud.